Hey guys, it's Miss Johnson and I'm here to bring you our notes video for Unit 3, Notes 2. Today we're talking about adding and subtracting polynomials. So, up at the top of your notes page, when we add polynomials, we add them by combining like terms. That's all we're looking for here is like terms. And remember that like terms are terms that have the same variable raised to the same power. After we combine those like terms, we always want to make sure that we write our answer in standard form. So those are the two things we're looking for when we're adding polynomials. Let's take a look at number one. We just want to combine the like terms that are given to us in this big long polynomial in number one. So the way that I do this is I want to first look through my terms and find the largest power. Here I have a power of 2, that's a constant, power of 1, power of 3, constant, 1, 3, 2. So I'm looking for the exponents, and the largest exponent that I see is this power of 3, and I see it in 2 spots. So I'm going to start with that, and by starting with the largest power, I'm going to naturally go in standard form, and then I'll be set with that whole second piece. So I look for I look for anything that has the power of 3. In this case, it's 2x to the third plus 8x to the third, which gives me 10x to the third. Once you're done with them, if it helps you, go ahead and cross them out, because then you know you've taken care of them. You don't need to look at them again. Then I decrease my powers from there. So I was looking at x to the third. Now I'm going to look at x to the second. And when I look for x to the second, I see 3x to the second there and negative 5x to the second there. So 3 minus 5 gives me negative 2x to the second. Again, I'm finished with those, so I can cross them out. Then the next one that I see is the negative 7x and 4x. Negative 7 plus 4 is negative 3x. So I can get rid of those. And I also see a 12 minus 5. Those are my constants at the end. 12 minus 5 gives me 7. So I'm going to add 7. And that is my simplified expression. Now, a lot of people get focused on the fact that they need an answer. Well, you're not really getting an answer as far as like one number. This is your answer, and it's just a simplified version of the polynomial. That's all we're doing here. Okay, let's take a look at number 2. In number 2, again, I want to start with the largest power. When I look through my powers, that's power of 2, power of 3, power of 1, constant 2, constant 1. So I see a power of 3 here, and it doesn't have any other like terms with it, so I'm just going to put that first. And then I'm finished with it. Then I go to the power of 2, and I have 3x squared and negative 2x squared. So 3 minus 2 gives me 1. That's plus just x squared. If it helps you to write the 1 in front of it, you certainly may. Then the negative 7x and negative 9x. Negative 7 and negative 9 gives me negative 16x. Notice, by the way, that when I combine these like terms, my powers haven't changed. You know, when I added 3x squared and negative 2x squared, I still have a power of 2. All I'm doing is looking at the coefficients here. And then the constants, I have 9 and 11. 9 plus 11 gives me 20. So that is my standard form polynomial. All right, so now we can add these things horizontally and we can add them vertically. If we add them horizontally, we're simply lining up the terms straight across and then combining them. One thing that sometimes helps people is if they rewrite it and put like terms together. You certainly may do that. You don't need to, but if you want to rewrite it and put like 4x squared plus 2x squared, then plus 3x plus 2x minus 2 plus 1, you can certainly do that. One thing to recognize, though, is a lot of times you'll see these two polynomials that are grouped in parentheses, and you think, ooh, parentheses, that means I need to do something. Sometimes those parentheses aren't performing any function for us. And the way I check is to make sure that there's nothing outside of them that needs to get distributed. This is just a positive 1. That doesn't need to get distributed. This is also just a positive 1. That doesn't need to get distributed. So really all I'm doing here is looking for the like terms like I did before. 4x squared and 2x squared is 6x squared. 3x and 2x is 5x. And then negative 2 and positive 1 is negative 1. So, oops, that's kind of an ugly box. Let's try that again. So that's just how I leave them horizontally and look for the like terms that way. But sometimes it helps people to line them up vertically. When we line them up vertically, we want to put like terms into columns. So we line the like terms one over the other, kind of like how I did when I would solve systems. And I'd have my x terms lined up, my y terms lined up, my equal signs lined up, constants lined up. In this case, we're just lining up the like terms, x squared, x, constants. Um, and that might help you if you're adding straight down that way. So when I add this way, I've got 4x squared over 2x squared. 4 plus 2 gives me 6. 6x squared. Then I have 3x plus 2x, which gives me 5x. And I have negative 2 and 1, which gives me negative 1. Okay, so you can do it horizontally or you can do it vertically, either way. If I take a look at number 3, let's say I line number 3 up vertically. So I'm going to take this whole second polynomial and I'm going to put it underneath the first one, but I'm going to make sure that the like terms are in columns. So underneath my 3x squared, I'm going to take this negative 7x squared. Then underneath my negative 4x, I'm going to put this 2x. And underneath the 8, I'm going to put the constant negative 5. So I lined them up vertically, and now I'm ready to add down the columns. 3 and negative 7 gives me negative 4. Negative 4 and 2 gives me negative 2. And 8 minus 5 gives me 3. So I have negative 4x minus 2x plus 3. Nothing else can be simplified there. There's no other like terms, and it's in standard form because my largest power is first. In number 4, if I go just straight across, I look at the 5x squared and the negative 3x squared. Those are my like terms. So the negative 3x squared is not in front here. This whole second polynomial is not in standard form. So I need to be really careful that I'm putting my like terms together and just not automatically putting the first two things together. So I have negative 3x squared, 5x squared, that's 2x squared. Those are done. Then I have negative 3x and 6x. Negative 3 plus 6 is 3, so plus 3x. Those are done. And then I have 4 minus 3, which is 1. All right. So now we get into subtracting. When we're subtracting polynomials, we need to distribute the negative or the subtraction sign, the minus sign, to each term behind it and then combine the like terms. So each term behind the subtraction sign will be its opposite and then subtracting will become addition. That's kind of how that works there. Okay, so if you look at this little example that's written down here, you can see that this minus sign went behind and made that negative 3x squared. Here, it went here to the negative x, and it's like minus a negative, which made that positive x. And then in the last one, it went to minus 5, so it's a negative 5 or minus 5. Okay, and then this is kind of what I was talking about before, how you can group your like terms together if you want. If you want to rewrite them so that they're next to each other, you can certainly do that. Okay. So let's take a look at number 5. In number 5, I have 4g to the third minus 5g minus 2g to the third plus 4g. So I need to take this subtraction symbol, and it doesn't affect anything in front of it, but it does affect everything behind it. So it's like distributing. The other way you can think of this is as plus a minus 1 times that whole thing, and then it's like taking a negative 1 and multiplying it throughout. Okay. So if I rewrite this now so that I have these things or have the negative distributed, the first set doesn't change. In the middle, I now have addition, and the second set of parentheses is its opposite. So negative 2g to the third minus 4g. And then I go back and combine my like terms because now I have nothing left to distribute. I've taken care of the negative. I just have a positive. I'm ready to go. So 4g to the third minus 2g to the third, those are like terms. That's going to give me 2g to the third. Gone, gone. Then I have negative 5g and negative 4g. That's negative 9g. Gone, gone. No other terms to look for. It's in standard form, so I'm good. Let's take a look at number 6. In number 6, again, this whole first set of parentheses doesn't change, but this subtraction sign that's in the middle distributes to both parts behind it. So my 3n squared plus 13n to the third plus 5n stays the same, and then I have adding negative 7n minus 4n to the third. So everything behind got distributed. I highly encourage you to do what I just did, circle this subtraction in the middle. So often we just go through a bunch of questions and assume that they're all addition and don't even pay attention to what's between the two. So make sure that you're looking at what's between the two, whether it's adding or subtracting. So now put my like terms together. Here's my power of 3, here's a power of 3. 13 minus 4 gives me 9. So 9n to the third, those are gone. Then I have this 3n squared and it doesn't have any like terms with it, so I'm just going to write it next by itself. That's gone. Then I have the 2n terms. 5 minus 7 gives me negative 2n, and that is my simplified version. Let's take a look at number 7. In number 7, the subtraction sign needs to distribute to everything behind it. So I'm going to take care of that. When I rewrite the, then my first one stays the same, 5y squared minus 3y plus 8. My subtraction becomes addition, and behind it I have a negative 4y squared plus 9. Everything behind it becomes its opposite. So this 9 that was negative is now positive. Now I can go back and find my like terms. Here's a squared, here's a squared. That's my biggest power. So 5 minus 4 gives me 1, which is just y squared. Those are gone. Then I have negative 3y that doesn't have any like terms, so that's just going to be next by itself. And then I have 8 and 9, which is 17. And there we go. Now, some of you may say it's kind of silly to rewrite all of these things, and you don't necessarily have to. If you can keep your work organized and you can pay attention to the things that you write down, it's just as easy for you to go make that a plus, make everything behind it opposite. So this is going to be a minus, that's going to be a positive, that's going to be a negative. Okay, so if you want to do that rather than rewriting the whole thing, I'm fine with that. Just make sure you can see your own handwriting and you keep yourself organized. So now let's talk about how we would write this. This one is a little bit tricky because you've got this xy here. Okay, now technically the degree of this xy is 2. So I'm going to start with my x squared term like I normally would, and I have 3 minus 4, which is negative 1. So negative x squared, negative 1x squared, but you don't need the 1. Then I'm going to go to this xy term. Okay, so I'm done with the squareds. Now I need to go to the negative 8xy and negative 6xy. Negative 8 minus 6 is negative 14. And again, I put this one second because it technically has a degree of 2, since each of these variables have a degree of 1. 1 and 1 makes 2. So then I put the xy term second, and then these y terms have just a degree of 1, so they come last. Now, negative 5 plus 2 gives me negative 3, so that's minus 3y. And there's my simplified version. All right, one last question here to take a look at, the word problem in number 9. In number 9, it says the total number of public school teachers T consists of 2 groups, elementary E and secondary S. From 1992 to 2003, the number in thousands of secondary teachers and total teachers can be modeled by the following equations, where n is the number of years. You've got 2 equations there. You've got an equation for the secondary, and you've got an equation for the total. And it says, find an equation that models the number of elementary teachers, E, for this time period. So I want to figure out what is E. Well, I know that the total is this, and that the secondary is this. So if I take the total and subtract the secondary, I'm going to get the elementary, because you're either an elementary or a secondary teacher. So I can subtract those two and get the elementary. So I have elementary is equal to total minus secondary. Well, now I know that total equals this, so I'm going to plug that in. The 58n plus 2,401. And the secondary is this, so I'm going to plug that in, minus, put it in parentheses. I need to make sure I put it in parentheses because I'm subtracting this whole thing. This gets distributed. So that's going to be a plus, that's going to be a minus, that's going to be a minus. Now I can combine my like terms. So my elementary school teachers looks like this. 58n minus, oops, that's supposed to be a 29. 58n minus 29n is 29n. And then 2,401 minus 949 is positive 1,452. So that's the expression. Technically, this is the number of teachers, so that's how I would label it. That's my expression for elementary school teachers. All right, that takes us to the end of our notes video for Unit 3, Notes 2. Thanks for listening, and don't forget to check your notes sheet off with Ms. Johnson, and I will see you later.